In this presentation, we're going to show you how to model a guitar neck in Aspire, utilising the new two-sided features of version 9. There are many users out there which use Vectric software already to create their guitar necks, and there are also many users out there which would like to be able to. We all use different techniques to get to where we want to, and the aim of this session is to teach just one of those ways where we are able to overcome a common problem when designing the guitar neck, and that seems to be the join between the neck and the headstock itself. So, before we go any further, I'm just going to hold up my hands and say I've never owned a guitar and I've never played a guitar. So, the knowledge that I have of guitars is actually very minimal. And if I'm honest, I actually thought the technicalities that built an acoustic or an electronic guitar were actually virtually all the same. I didn't realise until I did my research that there were so many differences that were involved when creating an actual guitar neck, which is only just half of the actual guitar. So when I did my research, what did I find out? So I found out that there's a lot more to a guitar neck than actually first meets the eye. And one of the first things that I noticed was that there are many different styles of neck available, and apparently these aid to the sound creation and also the playability of a guitar itself. Now, the one that we're going to be producing later on in this presentation is we're going to be using the Performing Artist profile as the starting point for our guitar neck. Other differences that come with guitar necks are the fact that all manufacturers seem to have their own differences in specifications. So there's no one set of specifications suits all. You'll find that the scale length, which is the length from the top of the guitar, so this is the guitar nut here, so it's the measurement from here all the way down to where the strings are attached at the base of the guitar here. And not only that, the amount of frets that each guitar neck has also differs depending on the manufacturer. So you'll see just some given specifications of the most common and classical acoustic guitars from the top three manufacturers. And also the spacing in between each of the frets also depends on these two factors. We then also have the curvature of the fretboard. Now, I honestly thought that the fretboard of a guitar neck was actually flat, and that was only until I actually seen this image and also a sideways profile of the actual fretboards that I realised that actually it was quite curved. And this is all dependent on these two common radiuses of a circle, and we just take a little cross section, and that then is the curvature of our fretboard. Other differences I found out during my research was that the neck width from the heel to the nut end is actually tapered, so it goes from around 2 inches and 1/8 to 1 3/4. And did also mention that the thickness also differs, so the top end at the nut end is normally thinner in thickness compared to the other end, the heel end, which is normally around about the 9th, 10th or 12th fret. Again, that also differs where the actual measurements are given. And wait, there's more. There's truss rods. Now, I didn't realise that guitars actually had truss rods in them, and this is basically just a metal bar which we can tighten, and that is then used to stabilise the curvature of the neck. Now, we need this in a guitar neck to obviously stop the climate around obviously affecting the wood. Obviously the wood will bow in certain conditions, and also the fact the tension of the strings could also bow the actual wooden neck as well. So to keep it all sounding nice and perfect, we use a truss rod, and these also come in two different sorts. So we can have a single-sided turning truss rod, or we can have a double-ended tightening truss rod as well. And the one we're actually going to design around is actually going to be the double adjusting truss rod, so one where we can adjust it at the top end and also the bottom. And lastly, there is also the headstock. Now, these come in different lengths. These also come at different angles. The angle apparently aids to the string tension, which also then aids to the sound that's produced. And then there's also the shapes, and there are oh so many shapes available, as you can see there. So then once I did all my research, I had to actually figure out which type of guitar that I actually wanted to create, and then I also had to then get a collection of all these specifications that I was actually going to work towards creating in the software. And these were the actual specifications that I ended up at for my performing artist style acoustic guitar neck. So we've got a neck of 18 inches, and you can see that we've got a headstock angle of 15 degrees, and we're going to use a scale length of 25 inches. And we're also going to use 20 frets in that as well. So once we've got our specification listed down, I then had to decide how I was actually going to construct our guitar neck. And there's also different ways that we can actually construct our guitar neck. Now this is another thing that I didn't realise as well. So there's the 3-piece guitar, which is where we actually create a separate headstock, and we use a different type of joint to join them, as you can see here. We also have the neck, which is going to be created in one, so the neck, and then also the fretboard would also be created separately as well. The second option is the 2-piece option, and this is actually going to be the option that we're going to demonstrate in this presentation. That's where we create the neck and headstock together, as you can see here, and then we're also going to create the fretboard, which is going to be glued and pressed in place afterwards. And the original design that I had was going to be a 1-piece, which is the neck, headstock and fretboard all in one go. It was only until I spoke to Tim Sway, who you'll also find a video on, who basically he creates something from nothing, so something from basically reclaimed and recycled materials, and he's doing a presentation on basically constructing a guitar base which we can actually use this guitar neck with. So you'll find his video online as well. So now that we've done our research and we've got a specification to work towards, and we've got how we actually are going to construct our guitar neck, the next thing we needed to think about really was how we're actually going to start creating the basic shape for our guitar neck. And there are many different ways which we could actually go about trying to achieve the result that we can see in the image, utilizing either the 2-rail sweep, the extrude or the create shape tool. But each different method differed in its complexity. Creating the longest part of the neck with varying heights and shapes was the easy part, but being able to achieve the angled headstock on one side of the job and have the other side of the job finish it off smoothly and seamlessly seemed to be rather tricky. As we tended to work with negative shapes to achieve the angled headstock, it made the join between the neck and the headstock anything but smooth. And that was until I stumbled upon a method that works and is very easy to implement, and that is what I'm about to show you. So essentially we actually want to create this shape. So this is a shape that represents the actual longest part of the neck, and then this is the angle of the headstock. And the way that we're actually going to achieve this is by what I've aptly named creating an invisible bed for our neck to lay on. This component you can see above is actually just a flat component, and it's raised because of the shape that's underneath it. And what I'm going to do now is I'm going to show you how we actually do this. So first of all, we have to just create a shape which actually represents the angle which we actually want to create for our headstock. So all I did is create this shape at 15 degrees. I then copied that component to the other side of our job, so we end up with this here, like so. Then what I did is I changed the combine mode of the component on the bottom side to negative. So then what happens then is that inverts the pixels, so basically it takes up the same space as the positive shape on the top side of the job. But because it's negative, what it does, it actually just removes those pixels. So it doesn't actually take them away, it actually removes the pixels up to that particular height. So that means when we add a shape on top of that, that actually adds onto the shape that's below it. Clever, huh? So what we're going to go ahead and do now is actually show you this in the software. So I'm just going to go ahead and open an existing file here. So I'm just going to go ahead and open the guitar neck starting base, and you'll find this in the files that are available as well. And you can see here all the vectors that are available to us. So we're currently on the top side of the job. This is a double-sided job, and you can see if I just go onto the layers drop down, we have a fair few layers which are full of different types of vectors. So if I just turn the visibility of some of these off, I can quickly show you what's on them. So we have the neck shape. So this is a singular shape which I created to create the tapered end and obviously just the rounded end of the heel. We then have the headstock shape, which I then added on to that. I then created an outline, which was basically those two shapes welded together. I then created the rails. Now this actually at the moment is just a copy of the outline, and we're going to show you how to actually create the rails for the two rail sweep shape in just a moment. And then we've also got a layer for the profile shapes, and we've also got the frets, which are basically just lines at the exact measurement, so basically the scale measurement for the guitar neck specification which we are designing towards. So if I just turn back on the outline, you'll see that these will be in the exact right position for our specified guitar neck. So the first thing that we're going to do is actually go ahead and create that underlying invisible bed shape which I mentioned. And to create this, we're going to utilize the two rail sweep tool. So we're going to need a pair of rails, and these are going to be easy to create as we just need to use the draw polyline tool. So select that and come in line with the actual top of the work area and just make this slightly wider than the actual width of the job itself, and just make sure that it's centrally aligned by grabbing the center of the line when it's selected and then just moving it until we get this point here which represents the actual center of the job, like so. Then what we want to do is create another copy at the other end of the job, and we can do this simply by just creating a copy of this line. So simply hold the center of the line again, hold control down, and just simply drag down the actual job like so. And you'll see that we should be able to snap to the exact center of the job at the very bottom as well. So just simply let go with the left mouse button, holding control still, and then you'll see that will create a copy. Then we can let go of control. So those are the rails. I'm just going to drag over my job to the left hand side. And now what I'm going to do is I'm going to create my profile shapes. So just to keep things organized, I'm just going to select my profile shapes layer like so. And what I'm going to do is I'm going to create the profile shape which I'm going to sweep between these two spans and create the 15-degree angle starting at the very start of our headstock. Now I know that it's 18 inches from here to the very end of my guitar neck, and I know that I've positioned my vectors half an inch starting from the bottom. So I know that I'm going to need to create a flat shape from the very end here to the actual top of my guitar neck. So that is actually going to be 18.5 inches. So simply select the draw polyline tool, click anywhere in the grey area, and you'll see that that will lock into place the first point of our span. Start to draw out the actual span itself, and you can see that the software will automatically give us a guideline to trace along. But as long as we've started to go in a particular direction, all we need to do is actually type out the length that we need. So if I type 18.5, you'll see in the bottom right hand corner we'll see value 18.5. Once that reads that, just hit enter, and that will create our first span. Then all we need to do is create the actual angled part of our profile. This is also very simple, so we can actually snap to the increments of whatever is set in our snapping options. If we press F4 when we're not in a tool, we'll be able to adjust those. Or we can actually still, again, we can use those keyboard shortcuts. So I'm going to type in 15 and the letter A. You'll see down the bottom right hand corner that will say A:15, which means the software is ready to take a length now at a 15-degree angle. And I'm just going to type in 9 inches there and press enter like so. And then all I'm going to do is I'm going to draw the actual polyline down so it meets exactly at the point with the rest of the flat part of our profile. And you'll see that the software has given us the guidelines to snap exactly into position. Now I'm just going to press the right mouse button, and that'll then exit the tool. So now all I need to do is select our rails. So I'm just going to drag from right to left and just drag from top to bottom just so it highlights both of those rails. Then I'm going to go into the modeling tab and select the two rail sweep. First thing I'm going to do is make sure that we check to use selection, and then I'm just going to make sure that the arrows for both of our rails go in the same direction, so from left to right. As you can see, the top one here, and that is also left to right. Now the actual direction doesn't matter, it just needs to make sure that both of the rails follow the same direction. Then what we're going to do is uncheck both of these options, so scale cross sections with width. So we're going to uncheck them and then uncheck the sweep between spans option as well. Then all we need to do is simply select the profile that we've created and then just give it a name. So I'm just going to call this invisible bed, as I do like that name. And all we need to do is simply click apply, like so. Now at the moment we can't actually see the 3D view. So all I'm going to do is I'm going to arrange my 2D and 3D views vertically so we can see them side by side. And you'll see that we've actually created the angle that we want, but it's just on the wrong side of the job. Now this is a very easy fix. All we need to do is right click one of the rails and then just click the option to swap the rail order and then click apply. And you'll see that that then will put that angle to the correct side of our job. Now all we need to do is simply just create a copy of that and put it on the other side. So let's exit the 2-rail sweep tool. Just going to press close on that. Select the component in the components tree and then right click, choose the option to copy to the other side, and in the 3D view now we should see a copy of the exact same thing on the opposite side of the job. So now what we need to do is just go ahead and create that negative version. So if we go over to the bottom side, so just simply click on this toggle switch here, and we'll know that we're in the bottom side because the arrow will be facing the bottom of the little block in the icon. The rulers are now have a color of orange, and also the components tree in brackets has the word bottom in it. So now what we're going to do is we're going to go ahead and create that invisible bed. So simply select the component on the bottom side, right click, and we're going to change the combine mode to subtract. And what this is going to do, because we're now going to create the negative model of this, it's going to actually create the same shape as the other side, and because it's now a negative shape, it's actually going to remove those pixels in this space. So essentially there is going to be a shape acting in that area, but it just means that you just can't see them because they're now subtracted and they've been removed. So I should then be able to create a flat shape on top of those, and it should then take upon the shape that's underneath. So let's go ahead and do that. So I'm just going to change combine mode to subtract. You'll see that that will now disappear. So what we're going to do is going to go back up to the top side of our job by just toggling the switch, and then we can think about creating the actual shapes for our guitar neck. Now I'm going to go back into my presentation here, as we're just going to remind ourselves quickly of the actual shapes that are involved in creating the actual guitar neck. So you can see we've got an image of a guitar neck at the top here, and all the different shapes which actually go along the actual length of a guitar itself. So you can see that we've got two flat areas at either end of the guitar, and you can see we've got a curve which actually lessens in width as it goes along the length, and also dependent on the actual type of profile that we're going to go for in the guitar neck, it actually changes height as well. So you can see here that we've got a flat area, and this bit is going to be the area which joins into the actual guitar base and is held into place in that section, and that is typically about 1 inch high. Then that smoothly transitions into the actual shape of the neck itself, so you can see we've got a nice curved profile, and that will then lessen in height to around about 9/10 of an inch. Now we're not going to actually create the profile at 9/10 of an inch because that is the height when it's actually included with the actual fretboard. Now the fretboard is a standard normally of about 1/4 of an inch thick, so we're going to minus 1/4 of an inch off 9/10 of an inch, so we're going to end up with roughly around about 0.65 for the actual start of the curvature here, and then by the time it actually reaches around about the first fret, we're going to end up with a height of 0.85, so minus 1/4 of an inch, we're going to end up with 6/10 of an inch. And then from here it's actually going to then smoothly transition into the flat shape of the headstock. Now here we don't actually have to remember to worry about the actual angle of that headstock because we're going to create this as a flat shape and we're just going to lie it onto that invisible bed which we have already created that angle for. So if we go back into the software, we can go ahead and now create all of these different profiles which we're going to need to actually sweep along our rails. So first of all, just go back into the software, and as we're going to be using the 2-rail sweep tool again, we're going to first of all start by creating our rails for our profile vectors to actually run along. So let's go ahead and select this outline vector, and that should be on the rails layer. So just select it and then press N on the keyboard to go into node editing mode. So we just literally just want to split this shape into 2 equal halves. So just zoom in to the top half, and you'll find that the midpoint should be highlighted between this top span, and you'll see that the mouse icon will also change, and simply hover over it and press the C button, and this will then insert a node into that midpoint and then cut the vector at that particular point, and do the same at the bottom. So you can see we've got the node, the midpoint node highlighted there. Simply type the letter C in there, and you'll see that we now should have 2 halves for our rails. So if I press escape on the keyboard, I should be able to now select this vector in 2 different parts, as you can see, like so. So we've got our rails. So now we literally just need to create our profile shapes. So I'm just going to go ahead and select our profile shapes layer, like so. And then we're just going to go ahead and draw some rectangles, as I find these are the easiest way to actually retain the height of our profile shapes. So we're going to start from the bottom up. So first of all, we're going to create the rail for our flat shape. So if we remember, that's going to be 1 inch high. So if we less 1/4 of an inch for the actual fretboard itself, we should end up with a height of 3/4 of an inch. Now we also need to remember the width of the guitar neck as well, which is 2.125. So 2 1/8. So if I just type in 2.125, hit the comma, and then type 0.75, hit enter, we should have our first profile shape. Then it's going to transition into the smooth arc, and that's now 9/10 of an inch. So again, it's going to less 1/4 of an inch. So same width, so 2.125, hit the comma, and then we're just going to type in the height. So it's going to be this time 0.65 and hit enter. Then that's going to transition into the actual smaller width profile shape with also a lesser height to 0.85. So we're going to less 1/4 of an inch on that, which leaves us with 0.65. So again, just drag the shape out, and it's going to be 1 3/4 inch, comma 0.6. Hit enter, like so. And then we move on to our headstock shape, which is obviously a flat shape with 3 inches in width, and it's going to be 0.6, so 6/10 of an inch in thickness. So this time I'm just going to type 3, 0.6, enter, and those are basically the starting shapes for our profiles. So let's go ahead. I'm just going to go into node editing mode so I can start editing these profile shapes. So I'm just going to press N on the keyboard. And close that. I'm just going to delete that rectangle that I just created. Select the first rectangle that we created, press N on the keyboard, and as this is a flat shape, all we need to do is actually just keep the height and the shape as it is, but we just need to delete the actual bottom span. So when we hover our mouse around this bottom span, and we've got the squiggly line next to the actual node editing icon, just simply press the letter D on the keyboard, and that will delete that span for us. And that's all we need to do for our first span. Now our next one up, we're going to create an arc within that's going to basically fill this space. And how we're going to do that is we're just going to select it first. We're going to delete the top span, so just hover over again and press D on the keyboard, and then we're going to hover over this one and change this one to an arc span. Now we can either press A on the keyboard or we can right click and press to arc, like so. And see, this will jump straight out to its full extent. Now what we want to do is simply drag the control node in the center, like so, and then we want to actually just pull out and align it to the actual top node of this leg here. And this, because this is going to basically restrict the height that we're going to create our arc to. And then when we join in the middle, you'll see that we will get a notification where we've got basically a cross of both of the guides, like so. and just simply let go of the left mouse. Then all we need to do is delete each side of the profile. And again, we just need to do this again for the one above. So just going to delete the top span, change this to an arc, drag the control node, match it up, and you'll see it can be done nice and quick, just like that. And again, the top one, because this is just going to be a flat shape for the headstock, which all we need to do is simply delete the actual bottom span. So press D on the keyboard once we've hovered that over. So now we've got everything for our profile shapes. What I'm going to do now is actually create some basically lines which are going to assist me in actually snapping these profile shapes in at the points where I need them. So first of all, I'm just going to copy this line up here that we drawn earlier. I'm just going to snap that to the center of the top of our headstock like so. And then what I'm going to do is I'm going to drag down and create a copy of this to snap at the center of this part of the actual headstock itself. So I'm just going to drag the center point, hold control and just drag it along the line that you can see, and when we get to this point we should be able to actually just hover at our center point over on the edge nodes, and you should just be able to pull back and snap that in the center like so. And again, just going to go ahead now and just drag a copy of that while holding control. Just make sure that we've got somewhere we can snap it to on a node like so, and then just drag it back to the center, and we'll be alerted by the software when we can snap it into the central position. Then we want to go ahead and create one at the 10th fret, so we know where to start our 9/10 high profile shape. So I'm just going to again get the center, hold control, and just count down as we snap into each one of the fret positions. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and just let go of the mouse there. And the last one we're going to position is actually 4 inches up from the bottom. So again, hold control down and snap it to the center point of the actual bottom of the vector, and then again just grab hold of it and then just start moving up the guide towards in the Y axis, and then literally just type in the value in the direction that we go in. So type 4, press enter, and that will then move that line 4 inches up in the axis that we started to move. So now we've got everything that we need to actually start creating our shape. So I'm just going to zoom out here. So I'm just going to go into the components layer, just so whatever we create is going to automatically go onto that layer, and then all we need to do is select our rails. So I'm going to go back into the modeling tab and the 2 rail sweep. I'm going to use the selection, and you can see at the moment that our rails are going from top to bottom. Now I actually want to create the shape going from bottom to top. So I'm just going to go ahead and reverse that rail, and then we can go ahead and actually start attaching our rails. Now I'm just going to, before we go ahead, I'm just going to make sure that we've got sweep between spans checked off, and also the scale cross sections with width. And then we're just going to go ahead and select our first rail and then attach it at the very start at the bottom. So if you just click here, you'll see that that will change color to white, and it'll also, our profile shape here will also now have a node added to it. And then if I add that then again to here, as I want that flat shape to go all the way to where we have this first line. So I'm just going to click here, and you'll see that that's now added that profile shape there, and that's resembled by the actual red node which matches the one on this profile shape. Then from here, the flat shape, I want that to smoothly transition into our first curved profile shape. So simply select that and then literally click at that second line, and you'll see that's been given a yellow node, and also in the profile shape that matches that shape there. If we go further up, we want this to smoothly transition to the smaller of the curved profile shapes. So all I need to do is simply select it, make sure it's selected, and just simply click around here like so, and that should be green. As you can see, it's green there. And from here to the top part of our headstock, we want this to actually transition from the small curve to the flat shape. So that's where we then select the later or the last of our profiles and just attach that to this part of our headstock like so. And then again, because we want from here to the very top end to be flat, we also just want to attach the same profile again, so just make sure it's selected. If I just drag up there, you see that's still selected, and then just attach that at the last line here like so, and you'll see that's denoted by the pink node on both the lines, which also matches the profile here. And we literally now have everything that we need to create our flat shape for our guitar neck. So all we need to do is give that a name. I'm just going to call that neck shape and hit apply. Now before I do that, I'm just going to go ahead and arrange the views vertically just so we can see what we're doing, and just click apply like so. And you see that has automatically taken on the shape that we wanted, which is the actual invisible bed which we placed here, and you can see that's laid straight on top of it exactly how we wanted. Now if we look at our guitar neck as well, you'll see how it smoothly transitions from a flat here into our curved arc which we specified for the guitar neck itself. And if you look at the Z level readings, and you'll see there's be a thickness that appears, you'll see that the actual profile has been maintained. So you've got 0.75 there, goes down to about 0.65, and by the end of the time I get to about here, it should be about 0.6, as you can see, and then it should end up at 0.6 for the actual thickness here as well. And you can see that nice smooth transition we've got from the neck actually onto the headstock there. And that is actually all we need to do for our guitar neck. Now we're actually ready to go ahead and toolpath this. So if I press close on the 2-round sweep form, it's going to go over to the toolpath tab, and just going to go into the material setup. It's going to align this to the center of our job. I'm just going to skip through this, so just to make sure that's in the center, and to make sure all this is okay, press OK, like so. And what we're going to do is we're going to go ahead and create just a finishing toolpath, as this is actually just an exercise just to learn the techniques in modeling, and we should always just remember that if we are cutting out anything in 3D, we should do our 3D roughing toolpath first. So I'm just going to go into our layers. I'm going to turn off the rails layer now. I'm just going to turn on the outline layer. This is going to be the vector that we're going to use for the finishing toolpath. So simply go into the finishing toolpath. I'm going to use an 1/8 inch ball nose tool. I'm going to use the selected vector, which is already selected, as you can see. I'm going to use a boundary offset of an 1/8, so equal to the width of the tool, as we want the tool to completely fit down the side of our guitar neck so we can actually get a full complete cut. You can use the raster style strategy, make it 90 degrees so it goes from top to bottom or bottom to top, and then just call this 3D finish, and then press calculate. And then all we need to do is do the same for the other side, but we do need to remember on the other side we need to just use the fluting toolpath to actually create the slot for our truss rod. So we can go ahead and just preview that while we're on the top side. So you can see that has created this for us. And I'm just going to go over to the bottom side now, and I'm just going to move this component as it's in the way to our components layer, and you'll see that we've got our vector ready to select. So I'm just going to press close here, go into the 3D finishing toolpath. Everything should be the same, so as long as we've got our vector selected, and just change the angle from 0 to 90 degrees, and then press calculate, and this again should create the other side. Now I know there's actually going to be an issue with this, and it's going to be to do with the fact that it's not going to be a complete cutout. And the reason for that is because the actual dead center of a tool, especially a ball nose tool, is the only part that actually ever cuts down to the actual specified depth, so the full flat level of that particular side's model. And we're going to end up with basically a lot of cusping and very thin film around the edge. So if I just preview this, I can show you exactly what I mean. Like so. So you can see here we've just started to break through in some areas here, but because we're actually using a ball nose tool, we're going to end up with a lot of basically a thin film that runs around the whole of the actual guitar, like so. So there is a way that we can actually resolve this, and what we need to do is actually create or force the actual toolpaths to actually create us an overcut. So how we do that is if we go over to the modeling tab again, so I'm just going to go back from the toolpaths by pressing this to switch over to the design side. And first of all I'm going to start by going to the top. So I'm just going to switch the icon here to the top side, like so. And what we need to do really is we need to basically decide on how much we actually want the tool to go past where it was originally cutting to. And I'm going to just choose a very small, minute amount of just 1/10 of an inch. And how we're actually going to apply this is by adding a zero plane and creating a negative base height, and that's basically just going to pull down the model below the actual modeling plane by that amount. But by doing that, you also shrink the model by that height because we actually have nothing on the other side. So if I just add a zero plane there, select it, and then go into the component properties, I'm just going to create a negative base height here of minus 1/10 of an inch. If I press spacebar, you'll see the model shrink. That's now shrunk by 1/10 of an inch. Now that's not good because obviously we were working to very specific specifications. So what we need to do now is actually, if we close this, we need to switch to the bottom side and then add that 1/10 of an inch back in, so we actually can then get the part of that model which has now been pulled down below that modeling plane. So if I add a zero plane here and add the height to 1/10 of an inch and press space, you'll see that that will now grow the actual model. So we've now got back the model, and you can see that the modeling plane sits right there, and the 1/10 of that actual model is now back in situ on the bottom side of the job. But what we have also accrued is some artificial pixels here, and this is just down to the actual way that the models are created using the pins. So what we need to do is actually just crop this zero plane to the actual shape that we're wanting to create. So with it highlighted, I'm just going to shift and select the vector like so, and then just use this option here to clear any component outside of the selected vectors. And you see that will now be removed like so. So now we've got exactly what we want. We've got the overcut because we've moved the actual zero plane or the actual modeling plane down by 1/10 of an inch. This will now force the tool to overcut that. We can now go back over to the Toolpaths tab and we can recalculate these toolpaths. So all I'm going to do is just press the Recalculate All button, and this will then automatically recalculate these toolpaths with that overcut in situ. And then we can go ahead and preview that. Now, if we were going to be cutting this out for real, we'd obviously add some tabs to the 3D model to make sure that we were actually going to keep the actual guitar neck in place when we did this. Otherwise, if we didn't, the actual guitar neck will actually come loose while we're actually cutting it out. And we'd also probably have to offset the actual vector that we've selected for our 3D toolpath, just to offset it outwards by the actual width of the actual tab that we want to keep. So they've all now been recalculated. I'm just going to go ahead and just preview those now. So I'm just going to reset this and then preview all sides like so. And we should now see that the guitar net is now free from the block like so. And I can just double click the waist area. You can see we've got our completed guitar neck shape. Now the only thing that's missing from this is the actual flute for our truss rod. So on this side we should see somewhere, if I just move this to the Components tab, and then all we need to do is literally turn on the rails layer and select this line here. This is going to be the line for our flute. Just press close, go into the fluting toolpath, and the exact depth that I was given from the manufacturer for this particular truss rod was 0.437 of an inch, so we're going to cut that into the material, and we're going to use a 1/4 inch ball nose for that, as it's a 1/4 inch wide. This is this truss rod. We're going to ramp at the start, which is going to be here. If it's not, we need to make sure that that is the start point of our vector. I'm going to ramp over a length of 1 inch. I'm going to make sure it's a nice smooth ramp, and we're going to project that onto the 3D model. And all we need to do then is simply press calculate, and we can preview that then like so. So if I just preview that, you'll see then we've got a nice fluted slot into our guitar net, which we're then going to be able to fit our truss rod into. So the only thing left to create here is our fretboard. Now this is in a separate file, So all I've done here is literally copy the neck vectors, as you remember that we've seen originally. So if I just go back up to the top side and just switch off all the layers just so you can see what shapes I'm copying over. So I'm literally copying the neck shape along with the frets into a different file with a thickness of 1/4 of an inch, and this is what we're going to use to create our fretboard. So I've already created a starter file with that in, so if I'm just going to go ahead and save this, and then all I'm going to do is just press File, Open, and it should be a fret starting base. So press File, Open, and we should see a fretboard starting base, and just press Open on that file. As you can see here are all the vectors. So if we remember back to the presentation, if I just get that up, and just going to escape out of this one for a moment, as it's one towards the very start, and let's bring it up. So if we remember back to this slide in the presentation, it goes on about basically the curvature which we apply to the actual fretboard. Now I'm actually creating a low profile guitar neck, so I want to use this larger radius circle to create a lower profile curve on the actual fretboard itself. So if we go into the software then, what we're going to do is we're going to start by actually creating our circle. So it's going to go into that and create the radius of 9.5 inches like so, and then I'm just going to go ahead and draw out the actual square, which is going to represent just basically the size, by the height and the length of the area which we're going to need to take a snippet out of this circle. So it's going to be 2.125 and 0.25. So hit enter, and you'll see that's now drawn that rectangle for us. If I just zoom in, what I'm going to do is grab the center of the top span and then just align that to the center of our circle, like so. So if I just let go there, and you'll see that that's the very smooth arc that's actually just going to travel through the 1/4 inch fretboard that we've got. And to cut this down, all we need to do is actually use the interactive trim tool. So if I just snip this part away, snip this part away, snip that part away, we're now left with the actual vector that we want. I'm just going to press close here, and I'm just going to node edit and delete this bottom span away, like so, and there we have the profile shape which we're going to sweep along our rails. Now at the moment we don't actually have any rails, but again we're just going to apply the same logic as we did last time. So we're going to node editing, cut this in the center at the bottom span, cut this in the center of the top span, and we now have 2 sets of rails. Simply select those, go into Modeling tab, again 2 rail sweep, use Selection, and we're not going to sweep between spans, we're just going to select our profile shape, just call this fretboard, like so, click apply, and this will now create our shape for us. And if we go into the 3D view, we'll see our fretboard in front of us. And if I just go down this angle here, you'll see that we've got that nice curvature applied to our fretboard, like so. And this should be 1/4 of an inch all the way through. So when it sits on top of the actual guitar neck above the truss rod and it's glued in place, that'll then complete the actual whole height of our guitar neck. So before we go ahead and create the toolpath for this, I'm just going to make sure that we've got everything in order. So I'm just going to move this to layer 1, and I'm just going to make sure we've got a vector that we can use for the outline. So I'm just going to turn off the rails layer and go on to the neck shape layer. Just make sure we've got a whole vector that we can use, like so, and the frets are also on. We've got everything that we need now. I'm just going to go over to the Toolpaths tab, set up my material. Now you can see this is exactly the same height as the block that I'm using, and it's going to go ahead and press OK. Again, it's going to go ahead and go straight into the 3D Finish tab, and it's going to go ahead and select the vector for this, choose the ball nose of 1/8 of an inch, have an 1/8 of an inch boundary offset, and again it's going to rest this at 90 degrees, and then press Calculate, like so. And then what we're going to do is going to use a profile toolpath to create the actual slots for our frets to go into. And that's going to be using a very, very small tool, as they're actually a 1/16 of an inch, I believe, in thickness. So let's go ahead and preview that toolpath, like so, and it's going to close this and create the profile toolpath. It's going to go into 2D view, just make sure our frets are selected. Start depth is going to be the top. Going to cut down to 1/16, so I'm just going to 1 divided by 16 equals key, and then I'm just going to use a 1/16 inch end mill to create the slots. Going to cut these on the actual vectors itself, and we're going to make sure that these are projected onto the model to make sure it goes throughout the whole of the actual thickness of the material. And then profile frets, press calculate, preview, and that then gives us all the slots. Then all we need to do is actually cut it out. So again, it's going to go into the profile toolpath. It's going to cut the whole of this out. It's going to put this Z equals in there. And for this, I'm just going to go ahead and use an 1/8 inch end mill. It's only very light material. Go around the outside of the vectors and just call this profile cutout, like so. Press calculate, preview, and we now should end up with a perfect fretboard for our guitar bass. And there you have it. I hope we've learnt a few tips and tricks along the way into the new two-sided features and obviously modelling in the two-sided environment in version 9. And thank you very much for watching.